here's the solution to one of the problems about midpoint and trapezoid rules. And this one is asking for these estimates with 25 subintervals, so you definitely want to use some kind of technology for this. I'll use the Mathematica notebook that I made with these commands in it, but if you just Google midpoint calculator or trapezoid calculator for integration, there are tons of these things online. And so all you have to do is to tell it the function, the interval, and the number of subintervals, and then it'll do these calculations for you. Notice it wants 6 decimal places here, so when I do my thing in Mathematica, I'm going to make sure I have plenty of decimal places to look at. The other thing that's weird about this is that at the bottom it's asking, the last two questions are asking about relative error as opposed to the actual absolute error. So I'll say something about what that means if you haven't seen that before. It's certainly consistent with what you say in physics and chemistry if you've had those classes. Or you could, again, just Google it. It's not a term specific to calculus, but I'll show you how to do that. And then the thing that might be causing issues with this is that they really do want the answer to be in scientific notation, which those of you who are in science are more familiar with probably than other people. There is a way in Mathematica, after you get a numerical answer, one of the little context things that popped up sometimes will give you the option of saying, I want that in scientific notation. But there is an actual Mathematica command to rewrite something in scientific notation if you really have no idea what that means. Okay, so the actual estimates M25 and T25, I'll get those from the app. So this is my, not the app, but the Mathematica notebook. So this was my Mathematica notebook with my code chunk for midpoint rule, and you can see I've set up the function cosine of pi times x over 2, making sure I have a space there so it knows that's multiplication, going from 1 to 4 using 25 subintervals. And I just hit enter, and my answer will be down here. Of course, it tells me all these other things as well. That's my a, that's my b, that's my n, and then it also tells me the delta x in case I care, which I do if I have to do error analysis. I care what the delta x is, but I do not care for this problem. So this will be the interval, and it wanted 6 decimal places, so I'm gonna just mark how far out that's going to be. So 1, 2, 3, 4, 5, 6, right there. And that will round correctly. I can see the next digits too, so it'll be negative 0.637563. Thing's going to happen with the trapezoid rule. This is another code chunk in that Mathematica notebook that I sent you to do this calculation. And again, with 6 decimal places, I'll go 1, 2, 3, 4, 5. And here, the 6th decimal place would, because the next decimal place after 3 is 6, then this will be rounded to a 4. So rounded to 6 decimal places, 0.634734. Absolute error. So to find the absolute error, to find the relative error, I need to, I have to have the actual value. You can't calculate relative error unless you know the actual value. And that's why we don't normally worry with relative error in our error bounds, because the whole point is that we don't know the actual value. So we're just trying to get any kind of bound at all on the absolute error. But in science, you often report relative error. So relative error, and I can see I missed my parentheses here. Relative error is going to be the difference in the actual and the estimate divided by the actual, and all of that should be an absolute value. I see here I closed my absolute value bracket too soon. It should be a positive number. So it doesn't hurt anything here. I just have to make sure I'm taking absolute value of what I have here. You can see in my output from Mathematica, when I got this value here, one of these context menus popped up and says scientific form. If I just click that, it's going to rewrite that using scientific notation. The mathematical command for that, if you don't see the context menu, is I can't spell scientific form. If you use the Mathematica command scientific form for a number and those capital S, capital F, that will rewrite your thing in scientific notation. Not that scientific notation is hard, but if you're not familiar, it might be better just to let the computer do it in this one case. It did want 2 decimal places, so I can see that the first 3 significant digits that I have here, in other words, the first digits beyond the zeros, round to 148, right? The next one's a 1, so 148 is correctly rounded. And that requires my decimal place to move 1, 2, 3 decimal places over to the right. So in scientific notation, that's 1.48 times 10 to the minus 3. Similarly, with this other one, my first 3 significant digits here. So ignoring all the leading zeros, I get 296, and that would be correctly rounded. So 296. And so 2.96, and for it to be 2.96, the decimal place needs to move 1, 2, 3 again. So 2.96 times 10 to the minus 3. So that would be my relative error in that case as well. Notice that relationship between the errors for trapezoid midpoints still have the same property. Dividing by the actual value doesn't change the relationship. They're roughly 2 to 1, where our midpoint error is roughly half of what our trapezoid error is. And we saw that with our theoretical upper bounds on the error, and we see it a lot of times in these problems where that really is the relationship between the real error that happens. So in this case, even to just those 3 significant digits, it's exactly twice. So the midpoint rule's error is half of what the trapezoid rule's error is, both absolute error and relative error.